This problem is about the bullet, and it says it is claimed that if a lead bullet goes fast enough, it can melt completely when it comes to a halt suddenly, and all its kinetic energy is converted into heat via friction. Find the minimum speed of a lead bullet. Initial temperature is 30 degrees Celsius for such an event to happen. I tried to look that up, and I couldn't find a single website that be talking about that the lead bullet actually on impact could melt. So that's why I guess the problem says it is claimed. So anyway, let's see what we have given. And that would be the original temperature of the lead. So T0 is given as 30 degrees Celsius, and that's practically it. What they want to know is the speed, so I'm going to write down V here. I'm going to write this towards the right just in case I need more space here, because here we should write down thermodynamic variables including the mass and so on. Notice that actually the mass isn't given. And then we're supposed to figure out what the velocity is, which when we looked in this chapter there isn't a single equation that includes velocity, so let's see how we could figure that out. On the mass, that the mass isn't given, we could have a hunch of that mass must divide somehow out of it. So if we take a bullet that is twice as massive as another lead bullet, then the speed of the two is still going to be the same, and the needed speed is still going to be the same for both of them, and they would melt at the same temperature. But in any case, that's actually what they want to figure out. Oh, I'm sorry, the velocity here is what they want to figure out. But we could say that, well, we probably do know what the melting temperature of lead is. So I'm going to give that as a given. And indeed the book says that for lead that melting point is 327.3 degrees Celsius. So the lead needs to heat up almost 300 degrees in order to get there. That means also that we definitely need the specific heat capacity for lead, which is given in another table. Top of my head, it's 128 joules per kilograms in Celsius degrees. And then it's supposed to melt, which means I'm going to give it a little bit more space here. Let's see if I can do that. Nope, can't do that. So I'm going to take the V off here and write it even further to the side. V is what they want to figure out, because then it has to melt. That means that we have to write down LF, which is given in the book, latent heat of fusion going from a solid to a liquid. My F just never looked nice here, so that's given. And as I said, the mass here, well, it's not given, but I think we can have a hunch that that somehow divides out. Okay, the lead starts at 30 degrees Celsius, and by the way, I couldn't find a good picture of such a bullet, so that's why you don't see one here, and maybe I should just draw one. Do I have some gray here for lead? Oh, there's some gray. There we go. And then I could, I guess, draw this bullet here. There we go. Good enough. Okay, and that bullet. Whoa, no, I don't have my nice blue anymore. There we go. That bullet starts at 30 degrees, and by the way, it has a certain speed. It starts at 30 degrees Celsius, heats itself up to the melting temperature. That means in order to get there, it has to be a certain amount of heat going in, which is the specific heat. So C times M times delta T. This here is the almost 300, it's like 297.3 Celsius degrees. And then it has to melt, which means there has to be more heat going in order to melt it, and I could call it QF, the one for the latent heat of fusion. So I have to add that to that, so mass times the LF that is given in the table as being, I think it's 23,200 joules per kilogram in order to melt lead, and that energy has to come from somewhere in order to melt the lead. Well, what does it have to do with velocity? And really the only conclusion we could come up with is that it's the kinetic energy, and of course when it comes to a stop, that kinetic energy has to go somewhere. And if you look back in the chapter on energy, then you find out that when a kinetic energy is gone in an inelastic collision, so it actually kind of puts us into energy and momentum chapters, that then goes into heat. So therefore the original kinetic energy becomes the heat in order to heat it up to the melting temperature, and then actually at the melting temperature in order to melt it. And so that kinetic energy is of course 1/2 mass times velocity squared. And as I said earlier, a hunch that mass divides out is justified. It appears in every term, so we can take it out. And then the velocity, well, just a couple of algebra steps here. Multiply by 2 and take the square root. So we're going to have 2 times c times m delta t plus m LF, and take the square root. And when you take the square root, you're going to come up with positive and negative result. Let's shoot it to the right, and so we come up with positive result. And everything is given in standard units, and so therefore for the velocity we have to come up with meters per second. Oh, then I did make that mistake. Whoops. I already divided the mass out, and then I wrote it down again. I should have just done this here. Could have avoided that mistake. So, in any case, oh yeah, and then I made a second mistake. That 1/2, you're getting rid of it. Of course, everything on the right hand side is multiplied with the 2. So we have 2 times the 128 times the 297.3 plus 2 times the, what was that, 23,200, and then take the square root of that, and the result of that is going to be in the neighborhood of like 1,000 feet per second. Of course, you're going to come up with meters per second, and you can see that, well, that kind of makes sense. That's kind of how fast bullets are, 1,000 feet per second or even faster. And so that's why it says there is the claim, so theoretically it's possible. If it actually happens, well, that's a different thing. You know, there's damage to the target, there's damage to the bullet, there's heat dissipating into the air as well as the target. So the bullet may or may not melt after all, and that's why they say in the problem that's a claim, and that's why possibly I couldn't find anything. In any case, you do come up with a velocity in meters per second.